Hello, everyone. Welcome. ITS 365. Let's see here. All right, so it's recording. Just letting some students in.
Come down, we can address this together.
Okay,
Since 10.
so we will begin our class today. As you know, we are all on Zoom, but we'll be back to class on Thursday. This is week 3. Okay, so let me go ahead and share screen. Okay, so I should be sharing the screen now. Okay, so you should be seeing right space, right? Right space there. Okay. All right. So yeah, so let's comment. All right. Okay, somebody who is not Henry Olson asked me to go over one problem. So I don't have the whiteboard, Henry, but I'll do that. I didn't set it up because I'm here. I could talk about it a little bit if you have questions, and then I will definitely do it in class when I've set up the whiteboard. Does that work, or do you want me to just talk a little bit about it today? Yeah, what? That will work. Okay, go over it on Thursday. Okay. Yeah. All right, great. Yeah, thanks. I did get we did get Slurm actually, or sorry, Scholar. So I'll try to have some of that. I would have had that today, but I believe you guys have your accounts now. I will provide a link for us to read all through that. And we don't need it right now, but it's more of a thing that you want to start reading about slowly, so that when the time comes that you need to access the system, you can. So we should have the accounts, which means you guys can log in, and then we just need the instructions on how to use it. And so the Scholar Cloud has provided us with a guide, and I do believe it. I read on it in that short text that it uses the Slurm system that Henry had talked about. So we'll talk a little bit more about that on Thursday. All right, so this week, as I said, we don't need the GPUs yet. Probably like middle of the semester is when we'll get to data sets that are bigger. But this week we're going to start something what I would say fun, interesting. So we did the first week we did a review of getting X and Y, how to convert any problem into a machine learning problem. And then last week you worked on the NumPy problems, and you're thinking just in terms of how to convert things. Really, you're mapping vectors to vectors. That's at the end of the day, the way that you want to think about it. So yeah, so today though, I always, when I do this class, especially the intro classes, I always start with a tool called Weka. And that's what we're going to cover today. Because what I like about Weka is that it allows you to see the whole machine learning pipeline without having to code any code, to write any code. So my experience, the students become so focused on the code that they kind of take their eyes off of, what they're really trying to do. And so that's why I like Weka, because in Weka, you're not distracted by the code. You're just distracted by the actual machine learning. And then also what's great about Weka, although it's a very nice tool, you start to run into the problems of why you need machine learning, more powerful machine learning, deep learning, etc. So it's a really nice. So this semester, I have some data sets, some new data sets that I was able to get related to cybersecurity. And so you guys will be playing with those. We'll talk about those on Thursday. But this will be your first like big challenge. If you want to call it that. It's a homework, but a challenge. And really the idea is I'm going to give you a homework assignment where you have data sets. So you'll have some data sets and you'll have to model them, etc. So today I'll kind of go over the whole tool and how it works. Weka is a tool I've been using, I'm pretty sure, since about 2008, probably. So I've been using it for a while, almost 15, 20 years. And it still looks almost exactly what it looked like back then, but it's been improved, underneath it. It's actually written in Java. It's written in Java. And they do have deep learning now. I know it's a separate version of Weka, I think. We're just using the classical because at this stage, it doesn't make much sense to spend too much time on their deep learning tools. We have so many and this stuff moves so quickly. But yeah, so we'll start with this tool. I think I've mentioned a couple of times to ask you guys to install Weka on your laptops. So it's you should have been able to do that. Hopefully, I have it on my laptop here, so I'll kind of start there. We also need a data set, right, to do machine learning. So all these problems that you did of how to get the X and the Y, right? So we need a data set for that. So let's take a look at that. All right, so we've covered this module, because this was the creating X and Y. This is the NumPy vectors. This is Weka here, basically. Okay, you can see I provided this data set. This is called the Iris data set. It's a .csv file, so there's a lot there to talk about. There's also the Weka RAM issues. Weka by default only has like 1 gig of RAM, maybe, or even less. Like actually, I think it's like 256 MB, maybe. But you can increment that to however much RAM you have. So it used to be that we had 8 gigs of RAM and we would do 6. You could take it up to 6 so you don't, exhaust all the resources. Nowadays, some of you might have 32 gigs of RAM. So, take it as far as you want. That will be a limiting factor because as you start doing machine learning, you have seen as matrices, matrix multiplications, etc. And that can really quickly start to consume a lot of memory. Imagine if you have you're doing a CIFAR 10, which is 60,000 by 32 by 32 by 3. It's a pretty big matrix. So that impacts memory, something like RAM, especially with a tool like Weka, which may not be so optimized for doing these kinds of operations. And then here I've added a few other data sets, day and hour. I believe this is a bicycle utilization data set. So we'll talk about that today, getting data from various sources. I've loaded the cybersecurity, because you guys are mostly cybersecurity majors, so I wanted to have a lot of cybersecurity data sets this semester, and I've been collecting them for you guys. But I also have like other data sets. So we'll talk about sources. I have the cybersecurity data sets on my GitHub. They should be on my GitHub. And then other ones, I'll show you where we can get them. So that's part of the conversation this week. There will be, as I said, a homework assignment, which is kind of like a challenge. And yeah. All right. So let's talk about Iris and CSV. So I think all of you know what CSV is, but usually in machine learning, this is very common, especially with normal size data sets. Let's say you're doing some data science for the Gary US Steel, right? and they collect data with their sensors, and they might have 200,000 samples of data, and they might collect like 100 columns, right, of data, the chemicals, temperature, wind rate, things like that. So at the end of the day, what they're going to give you is very likely an Excel spreadsheet, right? They're going to give you a .xlx file, one of those, right? And that's great. As you know, usually what you'll do, what I would suggest you do is just take that file on Windows. It's native to Windows, so take it on Windows, convert it. You can export to CSV, right? If you get something like that. And .csv is like, it stands for comma separated. It can also be tab separated, other symbols. So you got to be mindful of that. Weka helps you with that a little bit, but you just got to watch out for that. And there's a lot of tools nowadays on how to process this. This is where Python comes in, pandas, etc. So these are all, many available tools we have available. But in general, I'm just saying a pipeline would be, they'll give you an Excel spreadsheet, right? So a lot of the time you end up with CSV files, comma separated, which, as you know now, the X and the Y, so you have the rows are the samples and the columns are the features, and then your label is probably the last one or something like that. So you gotta slice it, right? Which you learn how to slice on last week. Now Weka, because it doesn't require any coding, we're not going to be using Python with Weka. So it has a lot of filters and a lot of buttons for this and that. So that's kind of what we're going to navigate this week. And really what my goal is, as I said, just to get you guys to focus more on the machine learning part, because really then what hopefully will happen is once you start looking at Python and PyTorch or TensorFlow or some JAX, some framework that you were using, you can always go back to Weka. Wait a minute, how did I do this in Weka? And the other thing that's really important, I think, in machine learning is to always start with certain data sets. I very much believe that. Like there's two data sets in particular that are really important. They're the IRIS data set, which is this one. Then there's also the MNIST data set. And then later on, there's the Scifart-10 data set. So these data sets are like the classic data sets in machine learning, and they teach you a lot of things to look at. And they're also very good at, you remember them, hopefully. And so you will always reference them back. Okay, how did I do this in IRIS? All of this is similar except this part. So I need to address this and so on. All right. As I think I've said many times, this class is really not about writing algorithms, right? At the end of the day, I'll explain an algorithm per week, maybe, and you guys hopefully will understand it. And then, that's just an algorithm in your toolbox. It's there. You can always use it, tweak it here and there. But for the most part, like the transformer, which was invented in 2017, has pretty much not changed since then. And they made ChatGPT out of it. And it's, the neural net itself is similar and they add things at the beginning and at the end. But my point is that it's not really in the algorithms that a lot of time is wasted. I mean, sometimes you can just grab an algorithm as is and use it. It's really the data, though. Changing that data to something that you need is challenging, right? That's always going to be, you got a program there. Weka can't help you, So that's the work, the bulk of it. Anyway, so obviously we have to start with something very simple. So we're starting with IRIS, the IRIS data set, which is this one. It's a CSV file. So you're going to need to download this one on your computer. Okay, so as you can see, it opened it for me in Excel, and that is your IRIS data set. So hopefully you guys are seeing it. I assume you guys are all viewing it. So I'm just gonna extend this over here. So this is actually, I don't remember when this paper was published. It was done by Fisher, who was doing research on these flowers called the iris flowers, which are these, I think, like purple flowers. And they did a study for biology, and they wanted to classify the species of this iris flower, basically. So I don't have a picture of the iris flower. You can look it up. But I don't have it here. I did have it on my computer. I just forgot to. But anyway, the iris flower, just purple looking flower, and it's got 3 species, which are Setosa, Virginica, and versicolor. You can see that the words are there. And then what Fisher did is he basically, probably himself, or sent out people he hired maybe or something to go in and study these plants and to measure. So for each plant, they would measure the sepal length, the sepal width, the petal length, and the petal width. Okay, so they would measure that. And based on those measurements, they would determine if it was a species Setosa, species Virginica, species versicolor. Now let's think of this scenario, because I think it's going to be really important later, right? Imagine that it requires a biologist who charges, I don't know, $50 an hour to go look for these plants, and it takes them probably a few days going into a wilderness or something to find it, right? My point is, it's very expensive. And then when they get there, each one of these measurements takes a special instrument. That takes an hour, and the instrument, for whatever reason, only works for like 2 plants and then it breaks. Just, I'm making this up, but it's really important. My point is, it's expensive to get these, right? Every one of those features, the sepal length, sepal width, petal length, petal width. So you collect all 4, that's 4 times what, so it's more expensive. Anyway, so remember that, as it should be important to the story. But the point is that what Fisher wanted was a model that, and we're not going to get into algorithms today. We're just going to know the names of many models. But we were going to try different models that can learn from the data, and learn if given a sepal length, a sepal width, a petal length, and a petal width, what type of species would that be, right? So that's, kind of the process there. So, okay, so hopefully you understand the problem. We want to know the number of rows. So actually, iris is really nice for several reasons. One of them is that the data set is not that big. So something like MNIST would be very difficult to visualize, right? It's much bigger data sets. CIFAR, the data sets get bigger, they get very complex. You're looking at a, US Steel data set, it's tough to, right? But iris is easy. It's meant to be easy. It's meant to be a good starting point. There's 150 samples. There's no missing data, and there's labels. Okay, so now this data is ready for machine learning. So the question that I would ask you guys, if anyone can tell me, is what are the dimensions of this? What is the dimension of X? What is the dimension of Y here for this data set? Okay, so X should be 150 by 4, because there's 150 samples. There's 4 columns for 4 features: the sepal length, sepal width, petal length, petal width. And then Y is 150 by 1. Now this, we can have two types of problems. Problems like, let's say we were predicting for this plant, the age of it. Is it 20 years old? Is it 40 years old? Is it 47 years old? How old is it? That would be, and remember this word because it's really important, that would be a regression problem. But instead, what we're trying to predict is we're trying to predict a class, a species of it. So this is a classification problem. We want to know if it's Setosa, Virginica, versicolor. In machine learning, we can't have words in the matrices. So we got to convert this to numbers. Like Setosa would be 0, Virginica would be 1, versicolor would be 2. Okay. But we would do that with our Python code, of course. But in Weka actually will do this for you. So we can give it a data set with labels like this, and it'll just deal with it. Okay. But this is just an example, remember, just to give you the pipeline. Some things are very easy in Weka, but unfortunately, it just doesn't have the power. However, I would say that it's a nice tool to have. I would say if you have a data set that it's 100,000 by 1,000, so 100,000 samples by 1,000 columns, run it through Weka. I mean, run it through Weka without having to get into anything else and just see, you know, you start to get a picture of what's going on. What are is any of the machine learning algorithms available in Weka? Will it provide decent results? You know, you want to look at that. That's called benchmarking. It's called establishing the baseline. And it's just like the data visualization aspect of it. So Weka is a great tool. Let's say that you had 5 million rows and 10,000 columns. That's a much larger data set. Does it make sense to fit it into Weka? Well, what I would say is just on a random basis, sample that 5 million rows into just 100,000. Just take on a sample basis, sample out some. Maybe try the 10,000 columns. If that's too big, there's some techniques to compress it that we'll talk about later in the semester, and run it through Weka. At the end of the day, it's just about seeing what you get, right? So getting a picture, like establishing what's going on. So it's a great tool for that, I think. Anyway, so I think we're ready. As you can imagine, this data set is like the best data set for this kind of thing. It's for machine learning. It's ready. Later on in this week, as I said, your homework will be, you know, to find a few data sets and perform the analysis on Weka. So in particular, I want to have a regression and a classification data set. And so we'll talk about that on Thursday. And then you will do the entire machine learning analytics, which is what I'm going to show you how to do today. So the objective of today would be for you to understand from beginning to end how to do the machine learning pipeline, obviously assuming we have a really good data set. So we already have the X and the Y, it's ready to go. You know, if we didn't, and we do have to do a lot of processing, then that's a little bit more difficult. All right, so I'm gonna go ahead and close this data set. We've talked about it already. Sure. Okay, so let's go back to the Weka document before we continue. So there is here a Weka RAM. And it's basically a screenshot of the file that you may need to modify for your homework. You're not going to have issues for Iris. So the file should be, this is just a, what does that say? Run Weka, I think. Let me see if I can. Oh, here. says run weka.ini. So that's the run weka.ini. You'll have to find it where you installed Weka in your machine. And then if you look in here, there's a flag. It's probably that one. Right, this one here, highlight it, and you just have to change this. That's the amount of RAM. By default, I think it says like 256, maybe nowadays 512 or even 1024. And you can see you can increment it to depending on how much RAM you have. So, okay. So anyway, that's something in case you get an error that you ran out of RAM memory, which is possible. Not for today, as I said, but for other data sets. Okay. So let's go back to contents. Okay, so you've seen that file, you have that information. The other two are these day CSV and hour CSV. These are data files. Similar, see there, they have the CSV format. You can see these files are a little bit bigger. All right. Oh, there we go. All right, so these files are a little bit bigger. You can see here you have how many samples you have. This one has actually not that big, 731 samples. This has got date, which is sequential. Now, dealing with data, sequential data, there's actually a library called SKTime for that. So you can try things like that. There's also RNN models that are sequential models. So there's quite a few things, but those are more like dynamic models, sequential models. Most of what we're doing, you know, for this first few weeks is very static. So notice here you have season, year, month, holiday, weekday. I think that says working day, weather, temps, a temp, hum, wind speed, casual, registered, and CNT was probably count. I believe, if I remember correctly, this is the bike data. I have to look it up a little bit. We'll have to find the link that describes what this means, but if I'm not mistaken, it is bike utilization. So this is the per day data. And it's just another data set that we can play with. And then there's the hourly data. And these are regression data because they were predicting, if you notice, I forgot to mention that it predicted something like count, which is a real valued number. So once again, this one, the hourly, I would assume has more. Yeah, this one has, notice this one starts to get larger, 17,380 samples. But not that many columns. It's got the season, the year, the month, the hour, the holiday, weekday, working day, weather, temp, a-temp, hum, wind speed, casual, register, and count. And count, again, is a regression value. It's probably the count of bikes. So there's some seasonality probably, with the weather and things like that. All right, so yeah, so these are just some data sets that we have. They're all formatted to work perfectly fine with Weka, so that's kind of what we're worried about today, the mechanics of how to get our tool to work. And then here's the homework. I'll be updating this. This is kind of just okay. All right, so that's the module. We've got all the information, we've got some data just to kind of start to learn. And we are on this one, Weka. So now you're probably wondering, you know, the program. You've all installed Anaconda and you know how to use that. And Anaconda is what we will be using most of the time. But like I said, it's a good practice to look at the Weka toolkit to basically benchmark and establish baselines. So now let's go ahead and take a look. So I already have the data set CSV here. So you should put it in some folder, right? You should put it in some folder. So let's go ahead and start Weka. So after you've installed it, so you type Weka, and it's that, this is the Waikato environment for knowledge analysis. That's the name that they gave it like more than 2 decades ago. Okay. It's a project supported by the University of New Zealand, Waikato University, I think, in New Zealand. I'm trying to move this. Okay. Yeah. All right. So it's a good toolkit. I think the name comes from the bird that is common over there. Okay, so there's basically several buttons here. There we go. All right, I wanted to show you that there's a menu up here as well. Okay, so the menu has several tools. In particular, one that's important is there's a package manager. So what that means is that, you know, this is a big application. Not all the algorithms and packages are installed by default. So if you needed something like libsvm, which is a special type of implementation of an algorithm, you would have to download it manually. But we're not going to do that because we'll be using deep learning. So we can just, it's just enough to use the ones that are provided by default. Okay. Usually then you're left with these buttons here, these 5 buttons, simple CLI, it's like a command line interface. There's Workbench, Knowledge Flow, Experimenter, and Explorer. Experimenter is a nice one because it allows you to actually set experiments. Like you have 3 models training on the same data set and you want to determine which one is better. We usually just run all 3 and whichever has the best metric wins, but statistically speaking, that's not complete. And usually as you learn in your stats class, you know, you have statistical tests of significance that you do, right? So you probably looked at those p-test or something like that. There's the t-test. So the experimenter allows you to run experiments like that where you're going to get a result that says, yes, this model was better, and that difference is statistically significant. So then it's more meaningful, basically. Does that make sense, guys, so far? Are there any questions? No questions? Okay, great. All right, so then that leaves us with the Explorer. So the Explorer is this button. That's usually where we're going to spend most of our time. Basically, it's, as the name implies, you're just exploring. So it's the data analytics, data visualization, whatever you want to call it. It's just a really quick procedure. Like I said, after today's class, you'll be experts in this. So it's very intuitive, very easy. It's been running for more than 20 years, so it works. It just works. Okay, but it has limitations, like the file cannot be gigantic because it's not optimized for that. It doesn't have all the algorithms, but it does have a neural network. A neural network that you will learn a lot about this semester called a multi-layer perceptron, or short for MLP. So you will learn about that one this semester. And that one's available here. So now let's get started. So what you do is you click on Explorer and then it'll open a window, such as this one. Actually, let me see if I can move this. Okay. Yeah. All right. So the idea then is we have this interface. So I'm going to go over the interface first, just give you some thoughts on how it works, what it is. And then from there, we'll start doing some actual machine learning. So at the bottom here, it says, welcome to the Weka Explorer. So Weka Explorer, got the little bird there. Okay. You got these white screens here that will fill up with data. And once you load the data set. And basically, it's just really some tabs. So if you notice, there's this tab called pre-process. Then you click on this one called classify. Once we have a data set, it'll become enabled. Then we have cluster, associate, select attribute, visualize. So those 6 tabs are basically it as far as the pipeline, the things that you can do. We have then some buttons here in this row for loading the data and modifying it, editing. And then here, this choose and this white bar here are basically the filters. So you can apply certain filters to the data, if necessary. Now, Weka automatically can take labels that are words and just convert them into numbers. So it's not even going to require a filter for that. But there are other filters that we can use. All right, so now let's go ahead and load the data set. So as you can see, it's telling you kind of what to do because this is the only thing highlighted. So we can go ahead and click on pre-process. And we're there. Then we need to select the file that we're going to load. So we can load a URL, a database. We can even generate synthetic data just to kind of try different things. Here, I'm going to load the famous Iris dataset. So I'm going to click on Open File. Now, it's really important here that we talk about data type. So the native data type or extension for Weka is this file called arff. And it's a specific format that they have. And sometimes it's better to take a file, let's say in CSV, convert it to arff, and then save it as an arff file to be used. Just keep in mind, a CSV is going to be very easy to visualize. Arff will have a lot of metadata in there, so it'll makes it more complex to use later with other applications. Okay, so let's go ahead and now another thing is we have to tell it what type of file we are looking for. Otherwise, it kind of doesn't know how to process it. So here, I'm going to go ahead and say that I am looking not for all files, which would show the CSV, but we want to specifically say CSV. You can see I highlighted it here. So now it knows that it's looking for a CSV. So I have my CSV on my desktop here on the computer. So I'm going to go to the desktop. and it should be one of these. Here, iris.csv. You can see it's here. So now we can click on open and you can see that it populated. So now you have all this data that really quickly, you can know things about your data set. So for instance, we know that we have 150 instances. We can see that here in this 150. There's 5 attributes, of which this includes the class species. You can see that we have the features here: sepal length, sepal width, petal length, petal width, and species. We also have these highlighted. So when we click on another one, the data changes. So if we go to sepal length and we go to this screen, we know that for all the values in that column, the minimum is 4.3, the maximum is 7.9, the mean is 5.843. The standard deviation is 0.828. So we have different the different values for it. Now, one really important thing to look at is this over here, the type. This type should be numeric for values like these. But for the species, where we're trying to predict the class, it needs to be nominal. If that, let's click on it. See, it is nominal. It's able to detect it easily because they were actually words. But if for some reason it doesn't know and it says numeric, it's going to treat that as a regression problem and try to predict real value numbers. So we have to change it to nominal. Now, in this case, we don't have to do it. But if we did have to do it, we would go to one of the filters over here. You would choose a filter. So it should be filters here. There's supervised and unsupervised. Unsupervised just means that the X's and the Y's are not required. So in this case, to change the Y from numeric to nominal, it's unsupervised. So I'm going to click on unsupervised. And this would be an attribute. So I'm going to click on attribute. And then I'm going to look for a filter called numeric to nominal. And there it is, numeric to nominal. Notice it gives you information about these. So then this is just an example. We'll do more of these, but just to illustrate. So numeric to nominal, you select it. Notice that it's now the filter that has been selected. Then you can click on this white space and it'll open a further dialog. And in this dialog, you specify which column you want to change. So in this case, it's column 5. So here you just put 5. You see that? You select that one. You can click save. Or maybe not. Oh, okay, sorry. You click OK. And then now, basically the filter is set, but you have to apply it. So this is, now nothing will happen because it's already nominal, but you click apply. And now if we look at the features, this one's numeric, 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 numeric. This one should still be nominal, and it is. Does that make sense, guys? Any questions? Okay. All right. So that's an important one example of how filters work. As I said, you'll be doing that later. Or we'll be doing more of that later. If we look at the features, we can see the values changing here. And then finally, we have species here. This is especially important because it basically shows you the number of features that are samples that we have, right? We're visualizing it per class. So this class, this data set has 3 classes, and each class has 50 samples each, which means that it has a total of 150 samples, but it's also a highly balanced data set. Machine learning loves highly balanced data sets. On the other end of that, machine learning does not love unbalanced data sets. So data sets where one class has more samples, way more samples than the other. I mean, nothing in like real data sets will be exactly perfect, but as long as they're close enough, it's okay. But if it's highly imbalanced, like for instance, fraud detection, right? So fraud detection in a bank, usually most transactions are going to be not fraud, hopefully. Right? So yeah, so that's basically very important, okay? To balance the data. For the individual features, we can also see the distribution of it per class. So that's interesting how some values are more related to class light blue, others have these values class red, and others have the, you know, so it's interesting how it provides. Sometimes you can make things out of these, but not all the time. Sometimes this is very unreadable, but it gives you an estimate. If the distributions are normal, you know, centered around 0, that kind of thing, or if they're towards one side, you know, it's part of the whole data analytics package. You start to like get a sense of these things and, you know. Anyway, so Iris would be like the nicest data set we have, basically. Our samples is highly balanced. Okay, you can see now also that these tabs have been enabled. So that means we can now perform machine learning. So I'm going to go ahead and I'm going to click on classify. Now in machine learning, you have to do certain things. So the best way that I like to describe this is, as I've said a couple of times, and I'll keep saying, everything in machine learning is competition. So everything is, okay, we're having a conference in 2024 in June. This is the data set, you know, train your models on it and then come to the competition. The question is, how do they assess who wins, right? So this is really important. So what you do is you have a pool of data, and then you're going to split that data, usually into the train set and the test set, or sometimes into the train set, a validation set, and a test set. So let's ignore the validation, and let's just stick with the train set and the test set. So we'll say 80% of the data is training data, 20% of the data is testing data. So that's how they assess performance in the competition. They'll take a 20% of the data set, usually selected randomly, maybe, and they'll keep it a secret. They won't show it to anyone. No one that's going to compete can see it. That's the evaluation data set. Then the train set is what they share with everyone. So everyone will take that data set, go try out their models, train them, all their neural networks, etc., and then hopefully get to a model that they think is good enough for the competition. When they go to the competition, they can demo how they do on the train set, but really the winner is going to be determined based on applying the model to the test set. You know, when you apply the model to the test set, what you will do is you'll get the inputs and you'll predict the outputs. But you can now compare those outputs to the actual outputs of the test set. Whoever gets the highest accuracy in that prediction would win, basically, right? So there's some kind of a metric. So this is the whole pipeline that we're gonna, by the end of the semester, certainly, this will become very clear. All right, so that's what we do. We need to figure out X and Y, number of N, M. Once we have that, we split it. Nobody will see the test set, but people can use the train set to train their models. Okay. So that means that we need a way to split the data. So here, Weka, it is very easy to do it with Weka. So it's got several options. So it's got one option here. If the data set is already split, like if we already had a train set and a test set, then we could use train set to train. Once the model is trained, it will appear down here. Then we right click on that and we would tell it, okay, now use this supplied test set. So we click on that bullet and we click on set, which, basically allows us to select a file. So that's how you do it. But in this case, we only have the one file, if you remember, that has 150 by 5. If I click on edit here, you can see that it opens the file, the CSV file here. So you can see I've got 150 rows and I've got my columns and everything. So the data is loaded. Okay. Grab a chair here. Down a little. All right. So basically then, what we're going to do is we're going to go back to classify here. And now we have a couple of ways of splitting the data. Two ways, basically. Again, this is another new concept, but we will be doing this several times this semester. So easy one is to split the data. We can set this to, let's say, 80%. So that means that's all we tell Weka. Weka will randomly split the data into 80% for train, 20% for test. Okay. There's this other one called tenfold cross-validation. This is a much more complex topic, so we will ignore that for now, and we will come back to it later. All right, so now that we've split the data, what we want to do is we want to train the data on 80% of the data set, and then we're going to evaluate our train model on the remaining 20%. Since Weka is just for like quick prototyping, all of this is done just by, setting a few parameters. So what do we need? First, we need to select which model we want to use. So there's a lot of models that are available here. In general, I use a handful. So you're going to click on choose here. And here you have all your classifiers. You have categorized by Bayesian, by functions, by Lacy, by rules and trees, and so on. In general, I like to use the trees, the Lacy, the functions, and the Bayes. Those are, generally speaking, the ones I use. So I always like to start with the Bayes. The naive is called naive Bayes. The reason why I like naive Bayes is because it's really fast. So I can get, you have a data set, you're really eager to see, okay, what am I going to get with this? Is this going to be a hard problem or an easy problem? And so naive Bayes can quickly get you there, but also it's the quickest, but also usually it doesn't have great performance. So it's not going to be the best, but at least it tells you the bottom. So it's going to start to give you that range of performance where it's going to say, oh, okay, it's not the greatest, but I know it can't get worse than this. Okay, so that's what we're going to, why we want to start with Bayes. So there's several in here, but we can choose naive Bayes, right? Notice that it's got the same thing. You click on the white space and you can modify things, etc. Any questions? Is that clear, guys? All right, so let's keep going. Okay, so now we've selected an algorithm, naive Bayes. We've got the data split into 80 and 20. Then there's really just two steps left. One step is here to make sure that the selected thing here is with a class we are trying to predict. So in this case, it's pretty easy. It should be nominal species, right? We're trying to predict whether it's Setosa, Virginica, or versicolor. And then we want to get basically a a printout of the results, okay? So in that case, I'm gonna hit on the start button here. And notice that the bird moved, but very little. It was almost instantaneous. However, don't be fooled by that. Iris is a tiny data set, and you will probably have to do a homework with MNIST using Weka, and that will not be as fast. All right, so great. Now that we've done this, you can see that we've got here a result. This is great because it actually saves the model, right? So if you notice, I right-click on it. So now I'm clicking on the train model. I can load the model, save the model, and I can reevaluate the model on new test samples, for instance. Although we don't have to do that for this one. So now the next step is to, now notice we are doing classification examples. We're going to do also regression examples. That's why I have that bicycle data, because you saw that the counts were more regression type values, not classes. So here for the classes, we're going to do a lecture just on what these metrics are, the equations, all that stuff. So believe me, it'll be very clear. If you took your statistics class already, you probably remember something like false positive, false negative, true positive, true negative. So that discussion in your stats course is basically ties to this. So the metrics that we want to, for now, I'm just going to highlight the metrics that are important to look at. So you want to look at this value here. That's called the accuracy. Then in here, you want to know that each row represents the label and also overall. So you can see here the class is Setosa, Versicolor, Virginica, and this is overall. That's why there's 4 rows. Then you're going to look at the metrics, which are precision, recall, and F measure. Okay? And notice that it gives you the values per class and overall. And finally, down here, we have a metric called a confusion matrix. All of these metrics are related to each other, so really, they all have to do with the confusion matrix, and I really like the confusion matrix. So what we want in the, let's start with the confusion matrix. Notice that it's 3 by 3 because there's 3 classes. What it's telling you is if it's class C, basically 8 samples were classified into C and 1 was misclassified into B. Then for the second row, it's saying for the class B, 0 samples were classified into C, 10 were classified into B, and 0 were misclassified into A. So basically that was perfect. For the test set, remember, this is the test set. That's why there's only like 30 samples here. And then the Setosa says also the same thing. Everything was classified as Setosa. So really there was only 1 misclassification. So basically a perfect confusion matrix is where all the values are on the diagonal. Okay. All right, so this is obviously just getting 1 misclassification is not a likely outcome in a much messier data set, but, you know, for this one, it's really great. After that, we want to look at precision, recall, and F measure. If we can only look at one of these, we want to look at F measure. F measure includes information from everything. So it's basically, if you can only look at one metric, that's the one to look at. Notice here the F measure, you have a 100% for Setosa, 95% for Versicolor, 94% for Virginica, and 96% overall. So this tells you that this data set is easy, but it's easier for it to detect Setosa than the other ones.
I have a quick question.
That's kind of, any questions?
Yeah. So
But if we
why
were
is it?
doing a competition, the winner would basically be whoever gets the highest scores over here, like consistently, right? And that's basically it. So this one is a very easy data set. So we'll use the other one as well. Although that one's a regression one. So it's a different set of metrics when it's a regression problem. So now we've done this. We, of course, want to achieve, this is 96. And you're like, I can do better than 96% F measure for overall. And certainly 94 for Virginica. So then what do? I'm going to try another data set. Or sorry, another model. So I'm going to go to choose. And I selected base. So now I'm going to pick functions. And in functions is where you have your neural network. And in that case, it'll be the multi-layer perceptron right there. You can just run it with default parameters. Nominal species is selected, so just hit start. Okay, notice that this one takes a second, right? Took a second. If we look at the diagonal, still only one misclassification, 100%, 95, 94, 96. Almost the exact same as base. You see that? And this is a neural net. We try it again, choose. Now I'm going to do Lacy. Lacy is the KNN. IBK is the K nearest neighbor algorithm. That's one that we're going to program from scratch. Actually, one of our first machine learning algorithms. So you click on IBK and you hit start. All right, thinking, it's done. This one is 190. No, sorry, I'm looking at it wrong. This one is 195, 94. It's the same. No improvement. Okay. Let's try another one. Choose. We're going to go to trees. Trees are interesting. You have two here that you should try. Decision trees and random forests. Okay. So usually, I mean, they're complex to, the algorithm is not straightforward. For those of you that have taken like breadth search first, DFS, BFS, it's some of that, but you know, it's trees basically. Okay, so usually you have a tree, which is one model, and then you have a random forest, which as the name implies, is a model of several trees. So in general, it can be more powerful. And then nowadays, there's something called XGBoost, which is even better. But let's see how it does. So if I always feel like, okay, if I'm going to bet on one algorithm other than neural nets, it'll probably be a forest. Right, so let's try decision trees. So the decision tree is the J48, this one. So write that down, J48. I've selected it, so now I'm going to hit start. Okay, we take a look. Ooh, look at that. Do you see that, guys? 1, 1, 1, 1. And there's no misclassifications, right? So although this is just one sample, yeah, I'm not surprised. So the decision tree did better, although the models were already really good. Let's try a random forest. And random forest actually was similar to the other models. So really, decision trees was the best. Let's try decision trees again, because sometimes depends on the randomization. So J48. Still one. So you can see it, for some reason, the decision tree is able to capture the data perfectly. Now, this won't always be, actually, almost always, this will not be the case, right? We're not going to get such good scores, etc. Although the models are getting better and better, but there's a lot of additional techniques being used for that. But anyway, that's basically the pipeline of using Weka. As you can see, you go from data set to select a few algorithms to obtaining the results. Any questions? Is this clear, guys? All right, so now let's go to that question I had in the beginning. It's really expensive to collect the data, right? It's really expensive. Could it be that we don't need the 4 features because each feature costs, a lot of money. So what if we could collect 3 features instead of 4? Is that possible? But the question is which ones, because we don't want to affect the performance of our model either. Wouldn't it be nice if we had a tool for that? And we do. We have this tab over here called select attributes. And then basically what we want to do is we want to look at the model and we want it to tell us, we want Weka to tell us if there's any features that are better at this than others. Because we want to almost ask it, hey, if I drop 1 or 2 features, what's going to happen to my performance? Well, we can actually do that. We just go here, click on ranker. So we want to rank the features. It's going to select the algorithm to use, so just say yes. It uses something called information gain, which is coming from information theory, which is, as Claude Shannon, again, for those of you that took cryptography, you remember the father of your major, basically, of the bits and everything. So information theory gives you these metrics about how to determine information, etc. And these can be used: mutual information, information gain, etc. All right, anyway, here we just use the algorithm, the technique, and this technique is going to give us a score that's going to allow us to rank the features. So we can tell it to use the full train set, or we can go a step further and do this 10-fold cross-validation. So what happens there is that it's going to do 10 iterations. It's going to randomly split the data into train and test, train, evaluate, then do it again, and it's going to repeat it 10 times. So usually it would be more robust because statistically speaking, the trend would start to appear. There would be an average, a mean, and a standard deviation. All right, so we need to select the class. Notice there's no class here. So we select species. And then I'm going to hit start. Okay, so it finished already, and it's telling me it's ranking by average merit, right? The feature. So it's telling me that the most important feature has a score of 1.388 plus or minus 0.03. So the attribute is petal length. So petal length is actually the most important, followed by 1.39 for petal length. So the first one is petal width, sorry. Then petal length. The third one drops from 1.3 to 0.68, and that's sepal length. And then finally, from 0.6 to 0.3, we get sepal width. So we definitely know that sepal width is the worst feature. So now the question is, what's going to happen to our models if we drop that feature? Is it easy to do? And the answer is that it is yes. So remember, please, it's sepal width. So we're going to go here. We're going to select sepal width right there. Selected it. And now I'm going to remove it. So I've removed it. Now I only have 3 features, the species, and I'm going to rerun the models. Any questions, guys? Questions? I thought somebody spoke. Okay, maybe not. So now we're just going to run the models again. Okay, everyone with me? Okay, so let's go ahead and do that. So I'm going to go back to classify. Here, to make the analysis more robust, I will click cross-validation. And now let's just do it again. So species is selected. Let's pick, let's start in order. So I'm going to do base. Okay, select it. I'm gonna hit start. Okay, so it finished and it says 194, 93, 96. So I believe some of those scores went down, but not by much. Okay. Let's try the multi-layer perceptron. Try that one. Okay. This one, 195, 96, 97. So basically no change, maybe even some improvement almost, but definitely no change. All right. And then let's just try one. Decision trees were really good in the last one. J48. So try it. And we get 99, 94, 95, 96. So basically, the results are still pretty good, and we've dropped one of the features. So what do you conclude? Well, you might conclude that it's very expensive to collect those features, and the model is still good, so maybe drop that one. So then you can continue doing this. So, until you determine, how many do you actually need? So let me go here. I'm going, oh, we want to select it. So I'm going to go back to select attributes. I'm going to do this again, select the class, species, hit start. And notice it ran really quickly, and it says now, yeah, sepal length would be the next one. So sepal length. So we'll go over here, sepal length. Remove it. Okay, now we only have two features. So once again, we select, let's select naive base, species, start. And what do we see? 194, 94, 96. So it's actually still pretty good. Okay, let's try multi-layer perceptron. Hit start. 193, 92, 95. So overall, not bad, not bad. Gonna try random forest, one last one. A random forest. Hit run. 100, 91, 90, 94. Okay, so this one, definitely we were at 100 with decision trees. Now we're in like the 90s for some of these, 91 overall. Okay, so some failure, but not much. So we can just keep doing this. Let's try it one last time. Select the class, species, hit start, and it said basically, okay, try it. Yeah, so here it's difficult to say. Petal length or petal width, they're almost the same value, I think. So let's just draw. Yeah, either one, I guess. So petal length. Notice that we are basically down to just one feature. We've dropped 3. Will it still be good? Well, only experimentally can we determine that. So we go back to classify. We only have one feature. We're going to select naive base again. Hit start. And the performance is, wow, 99, 93, 93, 95. Basically, we've dropped 3 of those and it's still doing really well. The confusion matrix, we have 6 misclassifications now, but not bad. All right, let's try multi-layer. Start. One 96, 90, 95. Still not bad. Let's try J48. Yeah. 99, 92, 92, 94. So as you can see, performance went down, but not super significantly. We can't drop any more features at that point. We just have the labels, so we can't do that. But yeah, that's kind of how it works. So hopefully you can see the process of feature ranking allows you to drop some features to save you money, cost, etc., to be more efficient, and we're still able to obtain good results. Any questions, guys? That's pretty much the pipeline. So I don't know if you have any particular questions. All clear. All right. Well, seems like it's all clear. All right. So now we're just going to do this a little bit more repetitively. We're going to repeat the exercise, but with the regression data. Now, there's a few other tabs in here, like this visualize. It just like shows correlations between the features. Now, I've gotten rid of a lot of features, so you don't really have that anymore, but it shows that. Clustering for unsupervised techniques. We'll cover these later in the semester, and so on. All right, so I'm going to close Iris because we've done the whole pipeline for classification, and we are able to evaluate performance. Now I'm going to repeat this for regression. Now, in general, we will be doing this all semester. Pretty much in machine learning, you live by these metrics, okay? And there's more, like if you're evaluating a ChatGPT that can summarize a paragraph, you know, you use something more than the F measure. There's going to be specific metrics just for that, okay? But, you know, that's kind of more advanced topic right now. Okay, so now we're going to do regression. So I'm going to close this window. You can say yes here. Then we need to download these files from the Brightspace. I'm going to click on Weka. I'm going to choose the smaller one, which is the daily, because the hourly was 17,000. And that's more of a homework for you guys, because it might take a while. Whereas this one is still small enough, and it gets you to see the pipeline for regression. So I'm going to hit download. Hopefully this data is clean, doesn't have any issues. But it could be a little messy, so yeah, so let me leave that open. Let's do downloads. I downloaded the file here. I've downloaded both of these actually. So I think Iris day. Okay, so day should be small enough. So I'm going to move this one just to the desktop for now. Okay, it's probably here. So there's day CSV. I'm going to move it. Okay. We can open it again. It's the file we had open. Okay, we've got that date column, which I will probably get rid of. I will also get rid of this sequence because remember, variables like this, like the ID, do not provide any information. This provides information if you're doing sequential data analysis, but we're not going to do that. So I will get rid of those two columns. Okay, so let's go ahead now. We have the data set. We know it's a CSV. So let's click Explorer. And it opened. Just like that. Okay, so we are going to now load that data file. So it's the same process. Open file. Desktop. You need to tell it that it's a CSV. And there it is. So it should be day. Okay, so click on day and hopefully it'll load, and there it is. So it loaded. That's great. Notice it's got, once again, 731 samples. There's 16 attributes, so 15 features and one predicted value. We're gonna get rid of this ID and the date. I'm gonna get rid of those two. So I'm gonna just do that and click remove. Okay. Then I have season, so I can look at season. I can look at year. I can look at, what does that say? Month. Holiday. And really what I should be looking at is up here, the data types. That's really what's going to break the model. So this one should be numeric. That's good. This one should be numeric. That's good. Numeric. Holiday is numeric. Weekday is numeric. Working day is numeric. Weather shift or weather. Yeah. SLT. That's going to be numeric. Temp, numeric. Atemp, numeric. Hum, numeric. This one almost has like a normal distribution, but this is a histogram of it. We've got wind speed. This one is like a distribution, but to one side, right? Like with a tail. Okay, numeric. Casual, numeric. Registered, numeric. And then we want to predict the count, right? So we want to predict how many, basically imagine the business wants to know, well, a lot of the questions are related to holiday, day of the week, day of the month, weather. And so it has to do with which day and the elements. And then you want to predict how many bikes am I going to rent that day? Maybe here in Chicago, right? So that's important because you can estimate your revenue for next year. You can estimate, your investment in bicycles. Maybe you're going to need to know how many new bicycles you need to have, things like that. That's kind of what you're maybe trying to do. And so we are going to predict count, which is a value from minimum 22 to 8,714. That must be per month or something. With a mean of 4,000 and a standard deviation of 1,937. You can see basically the histogram here. So about 4,000 was the most examples of it. Okay, rarely did they have very few bikes, so at least or a lot, but it's a good, yeah. All right, anyway, so that's kind of what we're going to take a look at here. So we are going to predict this value, but this is going to be a regression value, so it's numeric. So that means we need other algorithms and we need other performance metrics. So we leave this as numeric. So now we go to classify. Notice that Weka by default will not give you the same algorithms anymore. All the naive ones are gone. Why? Because those are classification algorithms for this implementation in Weka. So that's not going to help. In the functions, multi-layer perceptron will work for regression, so that's good. There's also something called linear regression, so we can try that. Simple linear regression, so I would just go with linear regression. So these two, linear regression and multi-layer perceptron, are going to be two of my algorithms to use. Then we can look at LaCie here. LaCie IBK does have a regression implementation, but I usually don't use that for that, so I'm going to maybe skip it for now. Although you guys for the homework can try it. Rules. And let's try trees. So in trees, although J48 is not available, random forest is available. Random forests can actually be good. There's some algorithms for regression. So we're going to try simple linear regression, multi-layer perceptron, and random forest. Okay? Does that make sense, guys? These are the three models because we're trying to predict not classes, but regression values. So let's start with linear regression. Okay, so this is probably something you saw in your statistics class, although we are going to go over all these when we start looking at neural nets, since there's actually a very strong connection there. All right, so make sure you pick the right variable. So count, it's numeric. Let's do let's do a cross-validation with 10. This is just a more robust way of doing things. And now let's hit start. Okay, so it finished. And it gave me a correlation of 1. Okay. So that's good. Correlation of 1. There's something called a coefficient. This is usually referred to as R. So then you square this. R squared, that's 1 square. So that's 1. So that's good. That's interesting that it did so well. Mean absolute error does not give you that much information, or root mean squared error. But the correlation coefficient is the R squared, which is this 1 squared, is the one to use. So actually, it did well based on this metric that I'm looking at here. Notice it also gives you the regression model, which interestingly is casual times 1 plus registered times 1, and that's equal to count. So that's all it needs according to this. Now, not all models will give you this very nice equation, but because this is a simple linear regression, apparently it does. Huh. Let me try 66. I'm just curious here. Okay, it finished. Once again, that's a 1. Okay. That's interesting. That must be very easy data. Okay, so let's now do cross-validation. Let's try another regression model. Let's do multi-layer perceptron. It is count. So hit start. Okay, see it's taking longer. It's thinking. It's a neural net and it's a bit slower. What is the value of the correlation? 0.99. Still pretty good. So it does well on this data set. Now, mind you, other data sets will not be as good, okay? Usually the correlation coefficient goes from 0 to 1. And so you don't want it to be 0, obviously. Because it is a squared R, so yeah, positive. I have some examples where I'll show you. That can be tricky sometimes. But yeah, I guess that's a 1. I mean, it's not like a 100, it's usually from 0 to 1. So this is from 0 to 1 on the high side. All right, well, okay. Let's try another one. Decision tree. Random forest. Start. Thinking, see, this one's taking a bit longer now. But you can see the result there. It is 0.99. So I would say if this is the correlation coefficient R, you square that. What is 0.99 squared? Oh. $98. So that's the our coefficient of determination is the R squared base. All right, so that's basically Weka that we looked at today. We could probably try the select attributes here as well. Let's just tell it that it should look at count. We want the ranker. Hit yes. Cross validation. Now we already saw in the linear regression that it liked casual and I can't remember the other one. I don't know if you guys remember, but oh, but it doesn't want to run. Doesn't want to. Yeah, so I don't think I can. Looks like it can't perform this task here. Because see that it's not highlighted. So yeah. All right, but we had an inclination from the linear regression model. We'd have to play. I'm sure there's a way. It's just not through this one. All right. Well, that's kind of the introduction to Weka. I'll stay for a few minutes if you guys have any questions. And then on Thursday, we're gonna pick up here. Basically, Thursday will be for you guys to use this tool. And you're gonna start getting some data, running through it, and that will be your homework assignment. So it'll just be a day to practice it. We're only gonna spend a week on Weka. So next week we are starting KNN, and we're gonna go back to NumPy and Anaconda. But I think, you know, with today's demo and then the time you'll have on Thursday, you should be able to master Weka really quickly. All right, like I said, let me go ahead and stop the share. And I will stop the recording here.